Clear?
Yes.
Okay, Zainab. So let's start the class without any delay. So, so we were doing the, so yes, we have to do the force on a current carrying conductor.
Yes, sir.
So is electromagnet is in your syllabus?
1 minute, sir. Let me check it.
Let's check and let me know.
The electromagnetism means the electric motor and all.
No, 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 no. Electromagnet means a kind of metal which is used, you can say a temporary magnet when the current is flown through it.
Yes, sir. It is there.
It is there.
Yes,
Okay.
sir.
So it's okay. So definitely only definition part is there, not more than that. Because this is not a, such a topic in which numericals and questions are involved. Like it will be directly straightforward. What is an electromagnet?
Yes, sir.
Yeah. So let's do this electromagnet. Yeah. So electromagnet, it's nothing but it's a metal, or you can say a magnet, basically, which is made by the flow of current. Okay, and a kind of long coil is like insulated copper wire is wrapped around a soft iron, and when when the current is passed through that wire, it becomes an electromagnet, a temporary magnet. Clear? So electromagnet is. Dear, sorry for the handwriting because like my pen is not working properly. So that's why I don't know what has happened to it. So that's why it's making a little bit more distorted shape of the writing. Okay. So
Yes,
please
sir.
let me know if you do, like if you're not able to understand anything.
Yes, sir.
Long kind of insulated Copper wire wrapped around iron core that is magnetized only when electric current is passed. So it becomes only magnet when the electric current is passed through that coil. Okay?
Yes, sir.
Yeah, so this is called an electromagnet. Clear? And one more thing is that the core of an electromagnet must be of soft iron, because basically you can say when the electric current is switched off, you can say when the flow of current is closed, so it become normal iron. Okay, it does not it does not behave like a magnet after switching off the current. Okay, that's why we use only soft iron core. Clear?
Yes, sir.
Okay. So let me write this thing. The core of an, when you will be having exams, Zainab?
Coming Monday, sir.
Coming Monday of physics. Oh, sorry, science.
Sorry, sir. Tuesday.
Tuesday, science.
Yes, sir.
Okay. So all the chapters are coming.
Yes, sir.
Must be of soft iron, because soft iron loses all of its magnetism when the current is when the current in the coil is switched off. Okay, that's why we use only soft iron core. Okay, Zana?
Yes, sir.
Okay, so factor affecting the strength of an electromagnet is basically if you increase the number of coils or increase the number of turns, magnetic field will increase. Yes or no?
Yes, sir. It will be.
And one more thing is that if you increase the current, the magnetic field also increase. Okay?
Yes, sir.
Yeah. So next, four factors. So for 10th class, it's like two are enough.
Sorry, sir.
I'm saying that for the 10th class point of view, two factors are enough.
Yes, sir.
Okay. Strength of an electromagnet. So this is all about the electromagnet. Okay. First is the number of coil, or number of coil means the basically the number of turns. The number of turns in the coil, you can say. If you increase the number of turns in the coil, the current or the magnetic field will increase. The more will be the powerful electromagnet. Next is the current. If you increase, obviously, if you increase the current flowing through that coil, the
The
magnetic
magnetic
field
field
also increase.
increase.
Flowing in the coil. Okay, Zainab?
Yes, sir.
Any doubt here now?
No, sir.
Okay. Yeah, so only this is the all about the electromagnet, not more than that. Electromagnet is not a topic. Basically, it's a kind of, you can say, theoretical question. What is electromagnet?
Yes, sir.
Okay. So nothing, you just have to write it down. And okay. So, and one more thing, I've basically pasting one direct straightforward difference between permanent magnet and electromagnet. Okay. Basically just it's the opposite. So that's why I'm pasting right here. Basically difference between an electromagnet and permanent magnet. It's nothing but bar magnet is a permanent magnet. You have seen bar magnet, the example that we have
Yes,
taken
sir.
earlier in the class. And
Yes, sir.
electromagnet is a temporary magnet, because when the current passes through it, it becomes magnet. If the current stops, it becomes a normal metal. Okay. And
Yes.
the weak like electromagnetic magnetic field of a permanent magnet is weak, but magnetic field of electromagnet is very high. Okay. Or like bar magnet is fixed, like it cannot be changed the value of the magnetic field, but the magnetic field of electromagnet can be changed by increasing the number of coils or increasing the value of current. Okay.
Yes, sir.
And the north pole and south pole is fixed of the permanent magnet, but the polarity of the electromagnet is not fixed, because if you if the current flows in the clockwise direction, it becomes south. If the current flows in the northward direction, it becomes north.
North.
So it depends on the direction of current. So we can make this we can change the poles of the
The
electromagnet according to ourselves. It's a like straightforward. So, but I have like it's not that important, but I've pasted it so that we can use the time efficiently in other topics, because this is a very, like you can say, not a very popular or general question. It's just a normal thing. Okay, just a normal comparison that's why I've pasted it right there. Okay.
yes, sir.
Yeah. So let's start the next topic, which is the force on a current carrying conductor. So force, obviously, if there is a electric field, so if there is an electric field, so obviously force will be there. Because if I say this thing, suppose this is a like tower, okay, which basically transports the electricity to the different part of the cities. So a certain region is fixed where the entry is restricted. It means that electric field is there. If you go beyond this restricted area, this tower will attract towards you. It will exert some force on you.
Yes,
Okay.
sir.
Yeah. So that's why whenever, or you can say, whenever there is a current flowing in a conductor, force also exerts on that conductor. Clear?
Yes, sir.
Sure. Let's do this thing. So, so Fleming left hand rule is used to basically, let me make this here. Yeah. So this is
Yes.
the force on a current carrying conductor. Simple. Like this chapter is, you can say, straightforward chapter. Just आपको you have to understand the theory a little bit. If you understand the electricity chapter well, it's like a cakewalk. I hope it's clear now. Okay.
Yes, sir.
So yeah. So obviously, if any field is there when a current carrying conductor, is placed in a magnetic field. If you if you place a current carrying conductor in a magnetic field, a mechanical force is exerted. Okay? Actually, pen, like it's very annoying right now. It's making my writing worse and worse. Mechanical force is exerted on the conductor which make it smooth. Yeah. So, and one more thing is that direction. Let's talk about the direction. The direction of force acting on a current carrying wire placed in a magnetic field. So all three are direction of magnetic field, current, and the can say just let me direction of magnetic field, current, and the direction of force. All three are perpendicular to each other, mutually perpendicular. Okay, each one is perpendicular to each of one of other. Okay.
So in 90 degrees, they'll be perpendicular.
Yes, it will be like this. Uh, have you seen a third? You can say. Have you seen a three axis graph?
No, sir.
This is like this. Okay, so the this dotted part shows that it's coming out of the screen. Okay, this is the x-axis, normal y-axis, but this is coming out of the screen. Suppose that you are sitting in the screen, this portion is coming out of your screen. Okay,
Yes, sir.
this is called z-axis. So all three are perpendicular to each other. You can see that all three are perpendicular to each other. One is going in this direction, another going is this direction, and one is coming out in this direction. Okay, so these three are perpendicular to each other. Clear?
Yes, sir. Got it.
Yeah, the direction of force, magnetic field, and current are mutually perpendicular to each other.
So that is what Fleming's left-hand rule states.
Yes. Basically, Fleming left hand rule tells you the direction of force and all the thing. And basically, you can see this thing when you take the hands, when you point out the finger and the thumb in the upward direction. Okay, so our finger becomes mutually perpendicular to each other. Okay,
Yes, sir.
first is perpendicular to the direction of motion, to the direction of current. Sorry. Second is perpendicular to the direction of magnetic field. Okay, so this is the clear, Zainab?
Yes, sir.
Yeah. So let's do this thing, Fleming left hand rule. So basically, Fleming left hand rule tell you the direction of magnetic field, electric current, and the force exerted by the magnetic field. Okay. So let me paste one picture of the hand so that you can understand it properly. So Fleming left hand rule can be there to state in the exams for a 3-mark question. Okay. Let me first state the Fleming left hand rule. Like it's basically let me is to hold like state that Fleming left hand rule. It's not a proper statement, it's just a kind of, you can say, direction to use the Fleming left hand rule. Okay. It's not a proper Fleming left hand rule. Hold the forefinger, the center finger, and the thumb of your left hand. Left hand at right angle. Right angle to one another. Adjust your hand in such a way that the finger points the points in the direction of magnetic field. Yeah. And center finger center finger points in the direction of current. Current, then the direction and points gives the direction of force. Sorry, motion, direction of motion. Points the direction of force or motion, you can say. Yeah.
Yes.
So this is this Fleming left hand rule. Clear, Zainab?
Yes, sir.
Any doubt? So basically, if you want to find out the current in a conductor, basically the magnetic field. So basically, if you take the left hand, your forefinger gives you the, if the current is flowing downwards in a conductor. Okay. So put your forefinger, the middle finger in the direction of current, and your forefinger will be perpendicular in the left hand side if the middle finger is in the downwards. Yes or no?
Yes, sir.
So basically it means that the forefinger will give you the direction of magnetic field. And if you basically take the thumb out towards you, thumb will be perpendicular to the forefinger.
Yes, sir.
It means that the direction of motion, or you can say the direction of force, will be in the will give you the basically the thumb will give the direction of motion or force. Clear, Zainab?
Yes, sir. Clear.
Okay. So
Yes, sir.
this you don't have to basically draw this diagram in the exam. You can draw this diagram as well. So current in this direction, this means that it's coming outward, out of the paper, out of the screen. Okay. This middle line, it's not the middle part, it's the out of the book, out of the plane. Okay. And this is magnetic field. Clear, Zainab?
Yes, sir.
Any doubt, dear?
No, sir.
Sure.
Yes, sir.
Okay. So let's do some questions based on this thing. Okay. Like you have domestic circuits, Zainab?
Yes, sir.
Okay.
About domestic topic, there is one small paragraph, right? That one
Okay.
is
Yeah.
what.
Yeah. A small paragraph. Like you just have to just explain that thing why, how basically the electric supply is there in the household circuits.
Yes, sir.
Okay. Okay. चलो ठीक है कोई नहीं. That's like basically that we have already done this thing in the electric chapter, तो easy हो जाएगा हमारे लिए करना. Don't worry. It's a small topic. I will try to finish it up right now, but if not, we will try to cover it up. Okay, so let's do some basic questions based on the Fleming's left hand rule. Okay. All the electric motor, electric generator, all the things are omitted now.
Sir.
Yes, Zainab?
Yes, sir. Yes,
Yes,
sir.
okay, 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 okay. It means that chapter is already half. Otherwise, this chapter is just like the electricity one. Electricity is much more much more, you can say, good chapter in comparison to this, because electricity chapter has the numericals and all the thing, but this chapter is completely concept based, conceptual chapter. Okay, so this question is saying that stream of positively charged particle, alpha particle, basically the positively charged particle are called as alpha particles, moving towards west. So in the west, suppose this is west, okay? So and deflected towards north by the magnetic field, the direction of magnetic field. So basically, if the current is in the west direction, plus first of all, place the fingers in the direction of current. Yes or no?
Yes, sir.
Okay. And the deflection is towards north. Zainab, are you there?
Yes, sir.
Okay. So if the question is asking what will be the direction of, let me snap this question. Like it's a
South,
question.
sir.
Just a second. This is a, like I've not taken the snaps of the question options. This is the question. The question is asking what will be the value of what will be the direction of the magnetic field. Place your finger towards west, the middle finger, which is the direction of current. Okay, and deflection is towards north. It means that the force is in the north. Yes or no?
Yes, sir.
So the force is in the north. Force gives you the direction. The thumb gives you the direction of force, na?
Yes, sir.
Okay. So, okay.
It is on the east, sorry, sir, west side.
Is on the
East side. Towards the east.
no. To no east. The current in the direction of west. The force is in the direction of north. So the direction of magnetic field will be outwards, not here.
Yes, sir.
It means that upwards. Clear है?
Yes, sir. Like towards the north, it is.
Yes. Clear है? Clear हो जाए ना?
Yes, sir.
Any doubt?
No, sir.
Sure.
Yes, sir.
Okay. So let's do one more question. Okay. So only this kind of questions will be there in the school exams. Okay. Like
Yes, sir.
what will be the direction of magnetic field, current? If any like any of the two things are given there, so you have to find it out. Just a second. Let me take the steps snip again. I think we'll be having a class on Tuesday. Next class on Tuesday, but the physics class will be on the next Saturday. Okay, chalo, theek hai. I will try somehow. Okay, is this now? So think you are sitting in a chamber with a one back, basically with your back to one wall. Okay. So an electric beam is moving horizontally from back wall towards the front wall. Suppose, okay, you are sitting here, ये back wall है, and this is front wall. Okay. And from back to the current beam, the light beam, electron. So if electron is going, it means that current is flowing, obviously,
Yes, sir.
and moving horizontally from backward towards front wall is deflected by a strong magnetic field towards the right side. It means that this side. Okay.
Yes, sir.
So force. Okay, we need to find the direction of magnetic field. So current again is in the left direction. Suppose
Yes.
you are sitting, basically the beam is going in the direction is in the front. So your middle finger will basically, uh, for you can say towards is this right and towards right. So it will be in the right direction, towards the right of the vertically downwards basically. Just a second, आपको मैं draw करके दिखा देता हूँ.
I didn't understand, sir.
Just a second, let me draw this thing. Suppose that you are sitting in a right, okay, chamber. So electron is going in this direction, or you can say, let's take this in from the first person view. Electron is going in this direction from back to front.
Yes, sir.
Okay. And the direction of current, direction of force is in this direction, yes or no? Right side, na? Towards the right side.
Yes, sir.
Towards the right side, we need the. So this is what? This is force. This is thumb basically.
Yes, sir.
Okay, just a second. Let me. This is thumb, and this is for middle finger current.
Yes, sir. The direction is towards the south.
Yes, downwards. Very good. It's correct. Very good. Not in the south, you will say vertically downwards because we are dealing in the 3D figure. Okay.
Yes, sir.
Okay, so your middle finger is in the direction of this, and thumb is in the direction of the right side. Okay. So your
Yes.
forefinger will give you the direction of vertically downwards. Okay, vertically.
Yes, sir.
Whenever you find these kinds of question, always draw this thing. Okay. Clear, Zainab?
Yes, sir.
Any doubt so far, dear?
No, sir.
Okay. Okay, let's do some more questions. Electric motor. Just give me a moment. Let me take some more questions. So four more questions are there in the form of MCQs. Let's do this question. I'm giving you 2 minutes, dear. Solve. Let's say 3 minutes to solve these four questions. Okay. Do this. Is it visible to you?
Yes, sir, it is visible.
Do this question.
So 25, 26, and 27.
24 be dear.
Yes. Done, sir.
All the questions?
Yes, sir.
Okay, that's great.
The first one's answer is into the page.
Okay, so magnetic field is in the direction, so forefinger. Electron beam is in the downward direction. So 24th, you are saying, what is your answer?
Into the page. See.
C, yes, it's correct. Into the page.
And the 25th one is 90 degrees. See?
Yes, very good. Into the page 90 degree, because this is the maximum, because everything is perpendicular to each other. Okay.
Yes,
So
sir.
when the force exerted, yes, next one,
26th one is 180 degree.
180 degree. Next one,
And 27th one is south to north.
south to north. So current is in the form of this direction, and the figure with the force south to north.
Yes, sir.
Current in this direction, south to north. 27th, okay. South to north. I don't think so, dear.
But it might be
क्योंकि
from north to south.
क्योंकि देखो, if you place your middle finger in the direction of current, okay,
Yes, sir.
okay, so current is in this direction.
Sorry, sir. It's
uh,
vertically upwards.
no, no, it will be downwards here. You are close, but it's downwards. Think a little bit. Think a
Yes,
little
sir.
bit.
Got it. I placed the finger on.
uh, okay, so it's in the direction of this, so it is vertically downwards. Clear?
Yes, sir.
Any doubt there?
No, sir.
Sure.
Yes,
Now
sir.
you got to know like how, like which kind of questions will be there in your school exams. So
Yes, sir.
okay, two more questions are there. Let's do them as well. Okay, is it visible?
Can you widen it up, sir?
Mm, no.
Yes, sir.
Okay, do this question.
Done, sir.
Okay.
So the first one is B, an unmagnetized iron bar.
Hmm.
And the 30th one is vertically downwards.
So 29th is okay, magnet. Okay. And 31 is
B,
B. Okay. Vertically downwards. Last one, try to think a little bit, dear.
so the 30th one.
Hmm. The question is not similar. Like the values are not similar to the this 27th one. The poles are changed. And the 29th one is wrong. It's a stationary charge. The question is saying basically a magnetic field will exert no force on a stationary charge. If the charge is not going, if it's stationary, it will magnetic field will not exert any kind of force. Okay.
Yes.
Ah, so this one is not. Do this thing a little bit.
Sir, is it A in the opposite, B, C, sir, opposite to the current direction?
No. Okay, last question. You have told me it's vertically downward if the poles are south to north. And if the poles are changed, so that only it will be directly upwards here.
Sir, I am getting always down on this one.
But just think a little bit. Now your south pole and north pole are changed.
Yes, sir.
Okay,
Yes, sir.
that's great. Just give me a moment. That's fine. Okay, so let's do some. Let me check some more questions. Hmm, I don't think so. That nothing. Okay. Okay, so we have done almost all the types of questions. Like this is completely this topic has no like very application based question. Only the kind you can say the objective types question can be there from this topic because it's not a type of topic which can be explained. Okay, so majority of the
Yes, sir.
question which will be there directly from the straightforward MCQ type questions. So
Yes, sir.
let's try to cover the last topic. We have 13 minutes, not 13, it's 12, I think. So I will try to cover that topic. Okay. So basically electric circuit, household circuit means, so we have three wires. Okay. So just give me a second. Let me take the picture if is there. Just give me a moment. Let me take the picture of one wire. Okay, so this is the question. Oh, this is the image. Because we'll be having the class in the next week. So I will try to cover this topic before my next class, domestic. circuits. Okay, so this is the picture of the domestic circuits. I will tell you the purpose of these different wires. Okay. Okay, so if try to cover the definitions like short circuit and earthing like your own, because I don't think कि हम लोग क्लास में वो चीज कवर कर पाएंगे अभी, क्योंकि नेक्स्ट क्लास हमारी नेक्स्ट सैटरडे ही होगी. ओके, सो डेफिनेशंस वगैरह आप देख लेना, just like short circuit and all this thing. I will tell you the use of these wires. ठीक है, so first one.
Wait a
Yeah,
minute, I know like some of the definitions.
okay, that's good. That's good. So basically there are three wires in this. Okay, so and these three wires are denoted like the coloring. Okay, so basically first wire is a live wire, and live wire is the wire which is, you can say, uh, which carries the current. Okay, so we have three wires: live wire, neutral wire, and earth wire. Earth wire is used to basically as a safety backup when the current is basically, if there is a short circuit or something. So that's why we use a earth wire. Okay,
Yes,
yes or
sir.
no? Okay.
Yes.
Okay, and neutral and live wire are those wire that is coming directly from the power supply. Okay, so
Yes.
just give me a second. So in which combination our household circuits are designed?
Domestic circuits.
Yes, domestic circuits. Can you tell me? Like I've taken this topic in the electricity chapter of combination of circuits of the resistors basically.
Third in parallel combination.
Yes, very good, in parallel combination. The live wire, neutral wire, and earth wire. The wire having red is called live wire. Basically, is basically distinguish the wire having, if the wire having red plastic, or you can say insulation. Okay, red plastic covering is made live wire. These two wires are coming from the neutral wire and the live wire coming from the directly from the power supply. Okay,
Yes, sir.
the wire having black plastic covering is made neutral wire, and the having green plastic covering is made earth wire. ठीक है?
Yes, sir.
So you can see this thing, each of the domestic circuit, in our domestic circuit, the combination is of basically parallel combination is there. It means that the power supply is basically giving you 220 volts. So all the sockets will have 220 volt of power supply. Clear?
Yes, sir.
Okay. So basically live wire, this is the electricity fuse, and live wire, it's basically passed through the electricity board fuse, and it comes into the electric meter. Okay. After that, This electric meter gives is basically extended to a new part, which is electric fuse. Electric fuse is basically to control the, you can say, is to avoid the electric short circuits and all the thing. It's a kind of safety instrument. Okay.
Yes, sir.
Okay, and basically electric fuse is used to basically to avoid the two circumstances, which is short circuiting and the overloading. If the, you can say, if the short circuit is there, electric field will cut the all the current to whole supply house, and if the overloading is there, it will also make the cut. Okay.
Yes, sir.
Yeah. So after that, this live wires are connected, or you can say, are, you can say, settled in the house, and the top pin of our household sockets is basically the earth wire. The top
Yes, sir.
pin, the with the bigger pin, you have seen the bigger pin.
Yes, sir.
Okay, so that bigger pin is basically the use of earth wire, which is directly going into the bottom of the surface, where you can say a metal plate is there. Okay, a metal plate is there, which basically you can say dispose all the current if the short circuit is there, and so it will basically you can say, if any of the person, you can say, touches the electrical appliance or anything which can basically leak the current, it will avoid this situation. Okay, that's why we use earth wire. Right now in India, it's very, it's not it's a very bad habit of the profit making things, they don't use any earth wire. They don't earth the power sockets. And why there therefore the majority of the cases, when you hear that there is a short circuit and all the things, the major breakout of the fire in the buildings is because of the uh, you can say non availability of the earth wire. Okay,
Yes.
so that's why it's very very important to connect the earth wire with the every socket that is present in the house.
Yes, sir.
It will avoid the first, the leakage of the current. If there is a short circuit, it will directly, the current will flow through directly to the earth wire, and it will dispose into the ground.
Yes, sir.
Okay. Yeah. And yeah, so it will also, you can see that all the three are, everything is connected with this single wire parallelly. So that's why.
Yes.
Clear, Zainab?
Yes, sir.
So this is this is a complete topic in which you can say um the whole, it's a small thing. So dear, you try to do this thing, because we don't have enough time right now. If अगर हमारी क्लास एक हो जाती पहले, अगर आपके एग्जाम, so सिर्फ this topic is only left in this chapter. Okay, in
It's
the next
fine,
class
sir.
I will explain this thing in the proper manner, don't worry. But do
Yes.
this thing, you just have to go through the electric fuse definition, earth wire, and the, you can say, short circuit definition and overloading definition. Only these three definitions are there in this topic. And why
Yes.
we use earth wire.
Yes,
I've told you
sir.
earth wires is used to basically avoid the flow of current into the household circuits. Okay?
Yes, sir. So overloading, right?
Yes. And short circuiting definition, when the live wire and neutral wire comes into the direct contact, short circuit happens. So ये चीज definition है. बस शॉर्ट
Yes.
सर्किट की ओवरलोडिंग में क्या होता है, व्हेन द पावर सप्लाई इज, व्हेन आप जो इलेक्ट्रिक्स आप जो आप ड्रॉ कर रहे होते हो, इलेक्ट्रिक करंट और इलेक्ट्रिक पावर इज ड्रॉन अप टू द,
Yes.
बियॉन्ड द लिमिट, सो ओवरलोडिंग. ठीक है.
Yes, sir.
या, so that is overloading. So okay, only these things are there, not more